Hello friends, welcome to this new video of Scratch coding series. In today's video we are going to explore prime numbers, what is a prime number and how to calculate a prime number using Scratch. So first of all, what is a prime number? So prime number is a mathematical number which is greater than 1 and it can be divided exactly by itself and 1. So for example 7, 17, 41, these numbers can only be divided by itself and 1. No other number can be a factor of these numbers. So from 1 to 100 there are several prime numbers, for example all are listed here, and these all numbers are divisible only by 1 and itself. So whenever we are given a number, we need to find out if it is a prime number or not. There are multiple methods to do that. The simplest one is to check for divisors. If a number is prime, then it will not have any other divisor other than 1 and itself. A quick method that we will be using in this video is to find out the square root of that number, root n, and then we will start by number 2 and up to root n, and we will check if all the numbers between 2 and root n can divide this particular number or not. If we can divide it, then it is not a prime number, otherwise it is a prime number. Another thing I wanted to tell you is that now all the Scratch videos are available in multiple languages. Just click the gear icon and select your language, and as you can see, number of languages are available. You can select the language that you are comfortable and start. Okay. So now let's move on to this. So as you can see, I have already set the backdrop and sprite here. Let's start by creating the click event. So when this green flag is clicked, first of all, we need to know the number that is given by the user. So we will use the sensing block ask and ask the user what the number is. Then after we will create a variable called number, and we will save the number that is given by the user to this variable. So now we have the number that is user has provided. Next we will use a counter variable which will be using as a divisor. We will divide the number by various values of this counter. So it serves two purposes. It also has a counter and also it will be a divisor. So we will set the initial value of the counter to 2. Okay, so why 2? Because we have to divide the user given number from 2 up to root n. 1 is not part, 1 and the number itself, they are not part of the divisor, so we will set the initial value as 2. Now we need to repeatedly divide number, so we will use the control flag repeat. Let's drag it here. Now we need to decide how many times we have to divide this particular number. For that we have already seen that the short method is square root of that number. So we'll drag operator block here and we will change it to square root of the number. Okay, now so the number of repetition is here. Okay, so now every time we divide this number by counter, we need to check if the division is proper or not. If there is modulus division, so if there is a remainder is 0 or not. For that we will use if condition. Okay, so if the condition in if will be decided by an operator that is equal to, okay, we'll perform modulo division here. So we'll divide number given by the user with counter and check if this modulus division returns a 0 or not. So this will be our if condition. Okay, so if this condition is true, that means the number is divisible by some number other than 1 and itself, that is from numbers 2 up to root n. So if this condition is true, then we can safely say that this number is not a prime number. So we'll just write that here. I will use the join operator. Okay, that this number is not a prime number, and we'll display that for a few seconds. Let's say 5. Okay. Now, if for first number we find that it is not a prime number, then there is no meaning of continuing this calculation. So we just use this stop all block. With that, the entire program will stop and will be able to display it here. Okay. So if condition is complete. Now for the sake of repetition of this process, we need to increase the value of counter to 1 each time, right? So for example, initial value is 2, so we'll first divide this number by 2, check the result. If it is 0, then it is not a prime number. Then we'll increase the value by 1, divide it by 3, and subsequently all the numbers up to square root of that number. So the repeat block is complete. Now after entire repeat block is complete and still we find that it is this if condition is false for each and every number, so finally we can conclude that this particular number is a prime number. So we can say that this number is a prime number. Okay, so that's how this entire program will look like. Now let's quickly run this program. Okay, enter a number, we'll enter 5 and say it's a prime number. Let's try again, enter 6. It's not a prime number, obviously it can be divided by 3 and 2. Let's try again some number, for example say 71. So 71 is a prime number, it can be divided by only 1 and 71. So you can try similarly other numbers and check yourself if that number is a prime number or not using scratch series. So that's all in this video. Stay tuned. Thank you very much. See you in the next video.